This is the first video tutorial on the MMD program, which can be used to assign individuals to sources and select informative genetic markers for source attribution. In this video, we describe how the working space of the program is organized and how it can be used for source attribution. The use of the program for self-attribution and selection of informative loci is described in two separate videos. The video tutorials focus on the Windows executable package, which can be downloaded as a zip file. Once the zip file has been extracted, you should see the working space of the program, which contains all you need to run it. These are the files and folders that contain the data and settings to run the program, and these contain program files that should not be removed or modified. Data and results of the program are stored in the project folder. It initially contains datasets that can be used to test the code. In particular, the files shown here will be used in the video tutorials. Other datasets used in our work can be downloaded and analyzed following the instructions given in these tutorials. Files in comma-separated value or CSV format can be opened with a text editor or Excel. For instance, a data file with Campylobacter isolates looks like this. It was opened with Notepad++, which is freely available and allows large data files to be opened in a more efficient way than Notepad. Each row in the file corresponds to a genotype, and columns give the loci of the genotypes. In this example, these are SNPs, which can take values from 1 to 4, corresponding to A, T, G, and C nucleotides. Negative numbers code for missing alleles. These take a different value for each genotype. Here, for example, missing alleles of the first genotype take the value -1. The files with POP extension contain the source of each genotype in the dataset. For example, this is the POP file for the Campylobacter dataset. For a given run with the MMD code, both the CSV and POP files should have the same name. Parameters needed to run the program are set in the MMD input text file, which can be opened with Notepad and looks like this. The settings are in the first column, and the second column is just for information. The working space includes more examples of files with the same format as the MMD input file, which can be used by just copying their content on the MMD input file. We'll now use the program for source attribution of Campylobacter isolates. The aim is to estimate the probability that a Campylobacter infection in humans originates from a given reservoir. In particular, we consider 5 Campylobacter reservoirs represented by 5 populations. The genotypes consist of 25,937 core genome SNPs, and the number of isolates in each population are given in this table. The first task is to set the parameters in the MMD input file. We first specify the name of the data file that we will use from the project folder. Note that the CSV extension should not be included in the name specified in the input file. The next entry specifies whether we want to do source attribution or self-attribution. For this example, we set it to capital A, which corresponds to source attribution. Note that all the names in the input file are case sensitive. We then write the name of the isolates to be attributed as it appears in the genotypes dataset. In this example, we set it to human. This entry gives a number of sources whose names should be listed in the following rows. The next item to be set is the number of loci to be used. Here we set it to the total number of core genome SNPs in our dataset. Source attribution for this number of loci will take about 20 minutes. So you may want to set this to a smaller number of loci for a faster calculation. The next entry to be specified is the value of the Q quantile used for the MMD method. We set it to 0.05, which was found to be suitable for this dataset. Another parameter that plays a role for both source attribution and self-attribution is the number of samples used for bootstrapping. This can be set to a large value without significantly affecting the runtime of the code. Finally, we set this entry to Y for yes, which means that the program will do attribution. In this particular example, we don't want to run loci selection based on entropy or redundancy, so we set the corresponding entries to N for no. Once the input file is ready, we double-click on the Run MMD VAT file to run the program. This opens a window that shows the progress of the calculation. It looks like this once the program has finished. The window shows a list of files that have been created in the project folder. The name of all files indicates the dataset analyzed, the value of the Q quantile used for the run, and the name of the attributed genotypes. File starting with PS summarizes the statistics of the probability of attribution to each source. More explicitly, the second column in the file gives the mean of the probability that any of the human isolates is attributed to the source given in the first column. The rest of columns summarize the uncertainty of the attribution probability in terms of standard deviation, the 2.5 percentile, and 97.5 percentile. The program also generates a PDF file with a bar chart for the probability distribution PS. Finally, the text file starting with PUS gives the probability that individual isolates from a known origin are attributed to each of the sources. The first column gives a number for each attributed genotype, which corresponds to the order it occupies in the genotype data file. And each row then gives the probability that a given isolate is attributed to each of the possible sources given in the heading of the file.